All right, well, let's get started. Guys, not Cal time in here. We're not waiting 15 minutes to get going. I'm Matheson, KJ6DZB, and I hail from Berkeley. I'm the East Bay Technical Specialist for Mesh. And we're going to talk about what it takes to build a mesh on the technical side. We all know we have 5 gigahertz allocations. It's a broadband segment that's used for any combination of high-speed 802.11 protocols. Amateur television, if you're in Southern California, please be aware of their, yes, he was not thrilled. There's other high bandwidth activities, and these channel divisions, well, they're separated and they're done regionally, so you need to check within your local region. I'm going to talk about what's going on here in the Bay Area as far as our channel spacing. It's a good idea to get a sense of what's going on in the spectrum at a site or at a repeater site. You do need to be aware of your neighbors. We need to be courteous, and as we have WISP, you really do. We're going to talk about channel spacing later, but we've a wireless internet service provider. We don't all have the luxury to have fiber optic or cable internet, so some people still do rely on that. Along the coast of California, it is how people get their internet. We've also got 2.4 and 3 gigahertz allocations. 3 gigahertz, it goes back and forth, but it's also being used by SSTV. So there's digital television as well as not slow scan. But 2.4 gigahertz is very crowded. You can alleviate some of that by using directional antennas. You know, if you're really shooting out a signal, you will, just like HF. So, broadband HamNet, formerly HSMM Mesh. The year was 2005. I had a WRT 54G. Yeah, they die. They're old technology. 20 years ago, we all had 802.11b and G. This was only 2.4 gigahertz equipment. It was only low starting price. You know, limited memory. WRT, formerly DDWRT, has grown to outgrow 32 megabyte equipment. So don't expect it to be able to fit the firmware inside of it. Low power, 12 dB high. Not much. We're going to look at how much power we really are running later. External antennas, diversity, not in. And you needed aftermarket antennas to be able to do something, even outside. You had to weather seal this stuff. This stuff was not meant to be outdoors on a tower, and it was not PoE. And the flash memory will wear out. These devices, any device, expect after 10 years, maybe 6 years, depends on how fast you're using the devices, what you're using them for. It's going to wear out. The equipment's going to wear out. So it's 2021. We've seen the wireless protocol standards increase since 2005. We've got 802.11g in, 2, and we're using 3 radios, and we're seeing speed increases. You may have a faster wireless connection on your iPhone than you're able to get over the USB port. So we're starting to employ multi-transceiver, multiple chains within the radio. Multi-in, multi-out. It's not just a single diversity picking the left or the right for the best signal. We're also getting very high gain antennas. This on the left here, my left, this is one of the panel antennas that Ubiquiti makes. On the other side is a Starlink dish. Now, it's not phase shaping and beam forming, but this is similar. Just two polarities. There's, of course, horizontal and vertical. So we're using a lot of gain. They stopped making these, so I don't know. Maybe they're just difficult to manufacture, but I think it was cool when I opened it up. So, has ham radio been left behind? We use FM, we use SS, sideband for digital modes. We've got DRM, we've got C4FM, P25. They're all packetized voice, but it's not very high speed. Amateur packet, enough said there. Narrowband, we've got Vera. We're starting to get some speeds, but the data rate's still limited by the FCC, and go talk to the president. They're working on. There was a temporary exemption for emergency purposes, but I feel that there need to be some pushes to try some higher speed communication protocols. And we've also got, well, Arden of course is utilizing 802.11n, 5 megabits to 120 megabits per second. Now you're starting to get a much wider signal, 5, 10, 20 megahertz, not 40 megahertz, but it is your home Wi-Fi may employ that. And LTE and Wi-Fi 6, but that is really a different talk. We're not here to talk about that. There is a push for more speed. This is the F4 HDK. It's a 500 kilobyte modem at 70 centimeters in the band. This is he's from France. We don't have permission to run it at 500 kilobits per second. We're limited to 100 kilohertz within the 70 centimeter band, and even then, you need to be aware. We need to be trying things like this, but we're fortunately limited by the FCC at the moment. He wants to continue to develop this. You can purchase this and get this in the U.S. for testing, but we have packet. We don't need mesh. Well, I'm sorry. Data packet technology was developed in the mid-'60s, and it was put into practice by Ampernet, which was established by 1970. We've got the main packet standard was from the 80s. So, anybody here deal with the OSI model? Understand? Okay, so we're going there. We're really going to talk about layer 2 and layer 3. We're talking about a physical layer, a data layer, and a network layer. We're able to play with the logical addressing and for our IP, our IP and our DNS space. We're able to share that. We're able to communicate with other computers. I'll touch back on that. So what do we do on a mesh network? Orv did a good job of talking about it. I'm just going to briefly hit it. Echo linking, video streaming, surveillance, remote weather monitoring, gas sensors, sensor networks, voice over IP, drag and drop file sharing, real-time chat. You can send APRS, you can get ADBS information, AIS relays, remote receivers and transmitters, SDRs. If you have enough bandwidth, you can get that baseband back over the mesh. Wireless-based reporting applications, collaborative computing, CAD, network visualization, which we're going to look at a little bit later, and satellite downlinks. If you need to get weather data, you can share it across your mesh network games, but no thermonuclear war. And of course, I like an accurate clock. I don't know anybody else who does WSJTX or any of the digital modes. It matters. So the packet exchange, it falls 20 years short of being modern. It uses the AX25. It's the packet framing. It's just a framing standard, and it's only layer 2, a data link only. Underlying AFSK, it lacks the data error correction. It's a logical packet exchange network that knows nothing about the other nodes on the air. Packets are sent, received, logically digipeated, or I-gated, or ACT. That's all they do. The originating node does not know the best path the way to send a packet. It's everybody on the network. And BBSs have to be accessed individually by unique simplex channels. Modern networking. Well-established means of high-speed computer-to-computer communication. So request to send data, if it needs, no problem, and they're high speed. We're dealing with high-speed networks. It's not wired, it's not fiber optic, but it is over an wireless connection. So domain names, we have address lookups, and the transport connections, all handled natively. Routing protocols to handle data and addresses being sent to the right place. You can connect to a computer and get information there. So everybody runs an ECOMNet. Neighborhood sends an observation via GMRS. EOC operator transcribes the message by hand on a piece of paper. At best, the EOC has a throughput of one ICS 213 form in 1 minute, at best. How fast can you write and transcribe? I'm not very good at it. They write that piece of paper on a message. 2 people shuttle a message around the EOC. from one pile to another, because I'm sure there's more than one form coming in, multiple radio operators. 3 minutes later, 5 minutes later. Then an additional person eventually keys the form into a packet, into a computer, and sends it over a packet network. So now it's finally being sent to wherever that message may need to be destined. It's kind of slow. So voice networks are slow to send messages. Here's my question. Will hams be able to provide alternative means of communication in modern emergencies? Value added. If we can provide situational awareness to agencies who manage emergencies, hams will be. But hams are going to have to step up, because this is a new kind of operator, one that was born with the internet. I was born in 1987. I started playing with... Okay, yeah, enough said, yeah. But does your local agency have a plan for when commercial data networks fail or get interrupted? Part 97 and Part 15 microwave links could help. You know, we're not just talking about using Arden firmware, we're talking about using wireless communication and using wireless communication to supplement that in an emergency. But I'm telling you, if spectrum allocations aren't defended, we're not going to have any spectrum to be able to do this on. The Nashville bombing interrupted internet, phone service, and there was no way around. They lost it for quite a bit. So we've got Arden. This is a community-developed code that uses OLSRD. We're going to talk about what that is in a moment. But custom firmware images for 4 manufacturers, 40 devices, 900 megahertz, 2.4 gigahertz, 3, 5, and maybe 10. Now, we're talking about interconnected networks. We're used to our internet. The internet is fault tolerant, but if one path goes down, there is another. Anybody follow what happened with Facebook? BGP, Border Gateway Protocol, but this is a large routing table that is shared, and it has to be updated. But your internet service provider, they go down. Well, you don't have a second internet connection, or maybe you do, but you've got 2. ISP goes down, telco gets interrupted. The larger internet is able to route around different paths. We are traditionally not able to, but we're employing that in. Now, hierarchical routing, just think about this. If you guys are interested, delve into it. Hierarchical routing, reactive routing. We're doing proactive routing and hybrid reactive proactive. And if you're interested in the Deep Space Network, where they're going with delay and disruption tolerant networks, being able to store and forward, being able to make sure you get a signal back from Mars, because you've got to shoot at where it's going to be in 9 minutes, and getting that information back. It's interesting. It's Lunar Gateway. So what is OLSRD? OLSRD is an optimized link state routing protocol. It's a routing protocol that's optimized for mobile ad hoc networks, but it can also be used on other wireless or ad hoc networks. It's proactive in its link state routing. It floods a topography table and to its neighbors and all of the other nodes in the network, which then compute optimized forwarding paths. So multi-point, point-to-point, it discovers the network. There's a little bit of a downside to this. There's a next generation of routing protocols that is a little bit better at this, because it is not aware of your RF link. It does not know whether you have a high bandwidth link or a low bandwidth link. It's going to compute an optimized path based on the number of packets it gets. So if it's getting a lot of packets over a 2 megabit connection or a 100 megabit connection, it does not know the difference. So be careful with that. I.e., you need to build a backbone. You need to plan and build according. So what is it doing? Well, it's receiving announcements from its other nodes, and it's responding with its own known routes, and it's calculating metric values for those links, and those are the ETX. And the metrics of 1 represent a perfect link. Well, it's all uphill from there. But of course, you get synchronized domain names and listed node services. Node location is all built into the node. So nodes are, you can input, you don't have to. It helps when you're mapping to know where a node is on the network. For just pointing, it's very informative. But this is all something this is all baked into the firmware. Mesh Chat and WinLink do some automatic discovery of services. As services are announced across the mesh, you can of course wait and look for the service. Oh, another Mesh Chat instance. I want to synchronize my messages with that client. So this is a Perl script that I run on the mesh. It was developed back in the HSMM, but it maps out not location, all of the nodes. Now, this was back from 2016. This was maybe 6, 7 nodes. We're growing. 2020, and of course, green RF links, blue or DTD. And of course, 2021. This is from the other day. So this is our local SF-WAM Bay Mesh network. We're growing. We're growing. Okay, so we're actually building a microwave propagation network. So please be aware there's atmospheric fluctuation. Now we're not dealing with 122 gigahertz, where the moisture in the air just like means it's a solid wall. But we're still dealing with 5 gigahertz, where you do fog and inversion layers are a significant factor in some of the links. Reflection path, shipping traffic. Container ship moves through the bay, some of the low-level links, you start getting 90-degree reflection. It was an interesting thing to find out. Path loss. The Earth is curved, and 5 gigahertz will go over the horizon. If you will go over the curvature of the Earth if you have enough elevation and power. But true line of sight versus predicted line of sight. There are a lot of prediction tools, but a prediction tool does not. You've got to actually go to the site. You need to do a visual survey. Can you see what you want to hit from the site? I live in an urban environment. We've got trees, eucalyptus groves, cranes that move on ships and lift things and get into the way, and then they go away. And of course, not enough elevation. We live in a very active terrain, and buildings and downtowns. So, but really, fog and inversion layers do play a role when you're shooting down into the bay. We get thermals that come up off of it, and we see signals fluctuate. So be prepared for that, and you need to plan as far as link margin goes. Use a lot of gain. You do not necessarily need to have wide sector coverage. If you need to hit something, you need to point gain at it. Yeah, you might have a 3-foot dish or 1-foot dish on your roof, but you want to have a signal. So I'm not going to go into the math, but free space path loss. It's still predicted. You've got to get out there and see what really is in the way. You can calculate free space path loss, but you can't calculate the free space path loss for fog and or a tree if you don't know about it. You just need to be aware of it. And honestly, if the tree's in the way, maybe you need to. Well, you can't cut it down, but you may need to shoot around it. We all have to deal with this. There are trees in the way. Can
they grow?
ErrorLink, Ubiquiti has a very solid tool. Get a login. It's free. I don't know if they track you and all other things, but for the most part, you can build you can model a very complex microwave network through all of their radios, and it gives you a data rate estimation. I mean, I think the most important thing is to really understand that at what point, what signals, at what link margin do I start to drop off? What am I going to expect out of these radios? Because, well, you got to look at it. Question?
The only problem with the ErrorLink is that it gives you a theory that, okay, point A to point B, you should be able to see it. But they do not include any new tall building in your path. That's the only problem.
No, you have to take this model and verify it in the real world. You've got to look. You take a nice camera. Look. Can you see it or not? But I tell you, you can export this into Google Earth. So if you have other mapping points, you have other things you need to lay out, you can overlay. You get a really good idea of what you're going to see. But as we said, hidden transmitter syndrome, and exposed receiver. I hear you, but you don't hear me. Well, that's bad for the modulation. we want these radios need to be aware of the other radios on the air. If they're not hearing a clear descend, they're gonna talk over somebody. I.e., we need to build that into our network. We need sectors. We need backbones. We do not want everybody on a single channel. That is not good for data. So, potential problems. Like I said, rotating obstructions. These ships were in ready standby for 5-6 years, and then all of a sudden they're gone. But in the meantime, they had cranes and they'd load things on there, and it got in the way. So, but sites don't always have the coverage you need. Repeater sites are key to regional coverage, and I'll tell you, no location is perfect. There's always going to be something, whether it's obtaining access, regular access, service, getting up to a site to maintain it. Some of these sites, I didn't see it for an entire year. I set it up that one day, and it held up. Did pretty well. Line of sight, mounting. How are you going to mount this? You've really got to think about it. I mean, whether you're on a tower, whether you need to haul in a non-penetrating mount, do you have to haul in all of the weight to to hold down the non-penetrating mount? And of course, HF and RFI. I run an HF station. I know a lot of other people do, especially with some of the WinLink stuffs. RFI is real. Ubiquiti has a little, it's not a flaw, I'm sure it's a feature, but they can reset themselves if they have voltage on one of the pairs for 30 seconds. So something to look out for. So we're building coverage. We have different types of antennas. They're not all the same. They're most certainly not all the same as far as their frequency response throughout the band. But you can't aim them. This omnidirectional that Ubiquiti makes for 2.4 and 5 gigahertz, great antennas, but you can't aim them, but you're probably going to have to send a directional signal at it. You're going to need a dish. You cannot expect omnidirectional and sector coverage to carry your entire mesh. You cannot use one type of antenna. You've really got to take a look at where you're trying to put the antenna. And they also have no noise rejection. So in 2.4 gigahertz, you put this in the bottom, that minus 2 channel, not so good. But I'll tell you, in 5 gigahertz, I'm really surprised how well an omnidirectional antenna propagates, because we do not have any other users on this band. The noise for the Bay Area is very low. I cannot tell you, but you need to be aware. Spectrum analyzers know what the spectrum looks like and if there are other signals there. Directional antennas. Ubiquiti has great self-contained design for their antennas, definitely compared to the WRT54G. They're metal though. They're heavy. This is compared to the LHGs, which are plastic. Big difference. But they also don't make a 37 dB antenna or a 30 dB antenna. These get kind of big. But you need to look at it. Is a sector antenna going to work? Quite literally. But I tell you, the Rocket lets you pick, and the Rocket is a one-and-all kind of radio. You can pair it with sectors, you can pair it with dishes, as long as it's got SMA connectors. So, and you can even, you got to put it in your car. You want some sort of you can pick and choose your antenna type, as long as it's working for what you need to put it, what kind of environment you need to put it in. So, safety, please. We are dealing with, well, we all know transmit power, dBi, the total dBm. A nanostation is about 28 dBm of transmit power, so plus it's 8 dB antenna. So you're dealing with 36 dBm of power. A nano bridge, you're stepping up. Your 28 dBm of transmit power, 18 dBi. You're starting to push a lot of power. A Rocket, 27 plus a 30 dBi antenna. You're up to like 75 watts. So please, when you're working on these things in your house, turn them down. I like my eyes. And of course, WRT54G. Yeah, well, maybe 12 dBm altogether. So what builds a strong network? This is what you're going to see inside the web interface of an Arden node. What builds a strong network, and what do you need to look for? Well, the percentage, the LQ and the NLQ are the percentage. Remember we said OLSRD is trading back and forth packets with other instances of itself. So it's keeping track of the loss. 30% of the packets are getting through, bad. Well, tolerable. It depends on what kind of, were you trying to send UDP traffic, are you trying to send TCP traffic? Is it going to request to resend? Are you sending video? If you're getting 80% video loss over, if you're getting 80% loss over a video link, you're losing packets. You're not going to get that video back. It's gone. And at a certain point, you're going to start to destabilize whatever you're doing with FFmpeg or whatever video service you're running. So you need to be, you got to be aware of this. 100%, great. If you can do that, 90%, 93%, good. We're getting there. Also be aware, DTD links are always 100%. But I'll tell you, if it's not 100%, something's going on. Something's messed up in your switch, or you're losing packets. Now, when a node comes online, this is going to have to self-generate. But if that's not 100%, and the node's been on, something's going on. Depends on how you've built your switching network. So, like I said, what are we looking for? These radios do automatically negotiate for modulation and for the best data rate based on the SNR. So you've got to go for gain. You're down at minus 80. The radio's not going to be able to. And now this is specific to every client. So a base station that's got multiple clients. Each of those clients is going to have a different data rate and data modulation rate on both ends of the link. So it can get very complex, but like I said, if you've got a high SNR, you're doing good. And this is also going to change if you're doing a 5 megahertz signal, 10 megahertz, or 20 megahertz. You're going to get a higher data rate when you're using a 20 megahertz radio. And strangely enough, the LHG outputs more power when it's in a 20 megahertz mode. So, channel segmentation. The links preserve the throughput. This is a smaller zoomed in image of SFWIM, the Bay Area Mesh Network. It is not all on one channel. We're using a number of channels. A lot of people can see across the bay, people can't see across the bay. We've got to shoot different directions. But because that noise floor is so low, if we're all, you can hear low noise, you can hear a station from behind you. You get that reflection off buildings. It is not, you've got to try to separate it. You've got to try to separate sectors. And if you have a backbone, you've got point-to-point links that are separate, because you begin to destabilize the network. You do not have the bandwidth if you've got everybody talking on. And as read the wiki. The wiki has a lot of good information on there. Arden has put together a lot of good resources and somebody spent a lot of time writing all that up, and it's a lot of good information. Please read it. It is very useful. So we've got this is our band plan here in the Bay Area. So we've got like San Francisco shooting south. There's different sector in Marin. We're shooting north from Richmond. There's also south, Cross Bay link. 2.4 gigahertz is pretty, like you said, using directional links, you can use it in multiple places. If you need a point-to-point link, it's a good option. And of course, 3 gigahertz, but the equipment is difficult to get, and the equipment may be aging out because of the 32 megabyte limitation. There isn't new 3 gigahertz equipment being made. So let's look a little bit at the different types of nodes and sectors we've got here. So a crossband hub, you may have you may be able to fit 2 channels onto 2 gigahertz. But we're using VLAN switches or even dumb switches to be able to trade those DTD packets in order to do crossband operations at a site. This is up near Fish Ranch Road in Oakland, and of course, point-to-point links sectors. And down on the bottom is actually 60 gig dish. They don't go very far, but you get a gigabit. There's Chris, Mr. Adams, working on the tower on New Year's Eve. This is a WA6KQB in Richmond, above the Richmond Hills, and this tower was just recently redone. But this also says you can go Mark 1, Mark 2. You can get stuff on the air with a basic port, with a basic switch, using using the injectors that come with it. And if ever you've confirmed that you're happy with sector coverage, you can look at it. What do we need to do better? If you can easily get back to the site, you can upgrade it. You can work on it. This is the new one. Raspberry Pi, a single PoE switch, the Edge switches XL10. Now this site also is completely off the grid. The repeater system as well as the mesh system. So the initial mesh install was not off the grid. It was on 120. You can go back and make it better. So here's a few pictures of before with a mess of cables and unmanaged switches. You can neaten it up by using a PoE switch. And these, of course, are all VLAN and manageable. So you can turn it off on specific ports and do all the tagging. So you have DTD and LAN and even WAN if you have WAN at a site. As we said before, so the GLAR 750, I eat things bigger than that for lunch. Pocket-sized tunnel server, 128 megabytes. Now, we're talking about 32, 64. It's future-proof, maybe. We'll see. But it's a great little device. If you need to run a tunnel server, and some of the features with the tunnel server itself, you can start to push the number of clients that you have connected. Cheap. I think it costs more than lunch, but still, it's tiny. But the HAP, oh my gosh, this is a great device, because even if you now, please, the PoE output is limited to 500 milliamps. That's one node. It starts to get weird if you try to plug multiple things into it, but you can use an external injector. And there's a neat little thing called a nano switch. These just came out. It's a PoE powered 4-port switch. So you can put it on a tower, run one cable up the tower, and have 3 ports on it. You can put 3 nodes on a tower. It's amazing. Now, Ubiquiti also makes some other stuff, because if you've got a 200-foot tower, you do not want to run wire all the way up it. So you could use fiber optic and run power separately. So that is an option if you have a large tower or a long run. The signal will degrade over Cat5e. So you can use fiber optic and run power and have your margin. But great little devices. You can stop by the table. We've got a few of them out. Here's another one. This one's running on AC. You can use a small battery. But as we talk about power, please, you're going to need to be aware. You're going to need to be aware of power margins. So you can use the PoE injector. It's going to give you 24-volt PoE, passive PoE, not active PoE, not PoE plus, not PoE plus plus. Go look it up. It's really complicated standard. We even had a Ubiquiti camera that was like, yeah, I'm PoE plus. I also run on 12 volts, but you don't run on 12 volts, but you run on 20 volts. But complicated. So at a site, are you going to use a UPS? The UPS may be able to have a system that charges, or it's just insulating it. So you're going to have a finite runtime. 3 days, 2 days, 5 minutes. And what kind of load is on that? With solar, you can most of the nodes, all of them. I mean, some of the smaller not microtechs, the GLs are 5-volt devices, but for the most part, they're 12 volt or 24 volt. They will run on 12 volts. You be aware of line voltage loss. So at the end of a 100-foot line, 12 volts is not going to be 12 volts. 24 volts is not going to be 24 volts. And that's why they do internally run on 12 volts, because they're expecting there to be some loss. But you want to feed them 24 volts, and it depends. It depends whether you're the managed charging or unmanaged charging, and or your ultimate power consumption. So some devices you can find 12-volt charge controllers. Some of the solar switches that Ubiquiti runs, 24 volts. So you got to run a 24-volt system. Each node is about 8 watts at 24 volts DC. That's for one node. But have solar and battery capacity for the equipment load, including the devices, the charge controllers. Those draw power too. Please calculate that. And make sure you have winter and summer capacity, because, well, our first run at UC Berkeley on top of Evans Hall went great for a whole year, and then it came back around in winter time, and it went to sleep. And it woke back up eventually when the sun came up, but it did not have enough capacity to make it through the winter nights. And, well, weatherproofing. Please, get a good container, weatherproof it, because if it gets wet, it's gonna go poof. It lets out the magic smoke. So, and I'm also gonna say, please buy local. If you get a good grade solar panel, it's gonna last. You know, the margins now with some of the newer solar panels, you're not gonna see as much degraded capacity, but Renogy, South Carolina, so there are some good, buy high grade panels. You're gonna get the most power out of the sun. This is a little diagram of what I put on. This is on Evans Hall. So using, of course, a solar switch, 70 amp hours of batteries. You know, I'm not going to go into battery technology, but lead acid is still affordable compared to lithium ion or lithium polymer technology. Lithium phosphate, those are much stable, but they're still expensive. They're very expensive. Nice little device though. 24 volt passive PoE. You've got a locally managed, you've got a local Wi-Fi access point inside this device, so you don't have to, for management. Its internal switch is unmanaged, so if you're trying to do, but it will pass the DTD packets, so you can't do any complicated switching with it. But it's a nice little device. You get a lot of information out of it. This is a non-penetrating mass. Batteries are inside. There are 4 nodes. We're not trying to run, you know, multiple nodes on a single port. And this was still alive after 1 year, about a month ago. Put in another node because, like I said, as your mesh grows, as you get different users, maybe you need to change an antenna out, or they die. You know, they do wear out. Here's a station in San Francisco. That's Greg there and Isaac. They're putting this up on top of one of the DOT buildings. Small, much less capacity, a single node. But like I said, that omnidirectional antenna it does a charm. If that's the only thing you can put into a site, then that's what you got to do. But it really does perform if you. Okay, cable. So. We all thought we knew cable. So Cat6 UTP, it's an unshielded twisted pair and crosstalk protection protocol. Remember, we're talking about what the specification for this cable is. Cat5e and Cat6a is crosstalk protection unshielded in the specification. Cat7a, crosstalk EMI protection with an overall cable shield in the specification. Now, please use shielded connectors. And near field antenna separation can be a problem. We were talking about this before, but you can buy Cat5e cable with shielded. In fact, we've found a Cat5e with a double jacketed burial grade cable. So there are a lot of different types of cable. You go on Amazon, you try to buy a Cat5e cable, Cat6 cable, you really don't know what you're going to get until you get it. It could be what you want, it could not be what you want. It could also be Cat7a cable that they're selling as Cat5e cable, calling it shielded. So you've got to really, and even especially if you're going to buy a spool of this stuff, you need to be sure of what you're buying. Ubiquiti does make a tough cable, but I think even as Orf has had trouble with it holding up in the weather, this stuff will degrade, UV degrade, and you can get moisture into the cable. That is bad. If copper is black, throw it away. It means there's been moisture intrusion. It sucks for coax and heliax runs, but it means that you've not sealed the cable and there's been moisture intrusion. You don't know what it can do to. Well, it's not going to work so good. Yeah. There's a lot of good satellite installation stuff. If you go to wish we could say we could go to Radio Shack anymore, but Home Depot's got a lot of this stuff. So you can pick this stuff up. You can run cable neatly on the exterior of your house. You can make it look as good as the cable install. Here's a few portable, well, not portable, these are just kind of stand up. Like I said, if you get a dish, you get a node, you can put it on your roof for a few weeks, as long as it doesn't blow off of your roof and onto your neighbors, or, through your roof. You can stand them up portably just to try before you're able to come up with a permanent mounting solution. And of course, on the left here, the dish is shooting all the way across the bay. The 120-degree dissector does not have the gain margin to get an adequate link across the bay. And of course, cameras. We all love cameras. I really enjoy cameras. There is something there. There is an omnidirectional antenna, but I will tell you before, omnidirectional antennas are not omnidirectional when you put them 1 foot away from something else. So, and I have no way of predicting and or modeling how it deforms the pattern, but be aware, you may want to use a sector if you're trying to get directional coverage in a direction. Field day. Field day is a really good way to stand up a portable node. I wouldn't, depending on how you run your field day setup, or how large it is, you may just want to use mesh to get in internet and run a local LAN, because, well, some of the vlogging programs, need to be on a local LAN. They do not NAT transition very well. But solar, yeah, that was my little rover. He got stolen, but there's another one. So that's the end. Check out SFWIM. Bay Mesh. We're out in the hallway. Please, if you're interested in getting going on mesh here in the Bay Area, come see us. We'll get you linked in. And if you're on the internet, well, of course, Arden. I have a basic camera page. I enjoy cameras and video. These are some of the publicly accessible ones, and of course my KJ6DZB. Google me, you'll find me. And this is some of the video we pull down. We've got up now about 18 cameras on the mesh, and 8 months, 9 months, a year we're going. We're capturing stills about every minute. And on the mesh you can see the MPEG-4s every 2 hours. Questions?
Yeah, can you go back one slide? The map.
Anyone watch the video?
Okay, the map, just FYI, if you're going to use the map, and I'll use mine for example. I'm in Redwood City. If you notice, I'm purple. That indicates that I've got a 2.4 gig map, which is true.
Okay.
However, you have to bring the map closer to you, and you'll find I got 5 nodes in there that are spoked out, but the map does not show those 5 unless you zoom in there to see, okay, does he got a 5 or 2 or what? And that's, so if you're living in a neighborhood, if you got a purple, so I want to put up a 5 gig, who's my 5 gig? Go to that person and just zoom in and then expand, see if that person does have a 5 gig, sharing that 2.4.
I challenge you to call us out, because all these stills are captured at different times of the mesh map, and like I said, we're growing week to week as far as new nodes.
Well, my 5.5 has been up for almost 2 years.
Okay.
Yeah. Yes.
So what would be the practical effect of using a non-MIMO antenna in a mesh setup that's 2x2?
You mean using a 2x2 versus an omnidirectional single chain
Suppose
radio?
you only had a single chain, what would that do to your partners in that? Say it, I mean, so I'll be specific.
You're not going to get
Let's
as
say-
much throughput.
Fair enough, but it doesn't affect the other people is my question.
It can affect the network. Because say this, if we've got a 20 megahertz channel,
Okay.
and it's using the full 70 megabits per second, and you're the 1 megabit per second radio on there, and it needs to resend something to you, it's going to have to send a lot. You're going to want in 1 megabit per second.
It's
going to take a
the
lot
time
longer
size.
than if you're a 70 megabit per second RxTX mode.
But is that saying that you should tell the people that are not using 2x2 to just go away? No.
Upgrade. There's no reason we can't get you equipment
No.
that's already 2x.
I get it, but I mean, how strong do you have to be in that message?
I will. We don't have a.
It'll work a lot better. Just tell them that.
No.
It will. It will. Honestly, I'd take that radio and use it for an access point at home if you want.
Fair enough. That's
Yeah.
We've had some people, some arguments where people say, well, I can't afford it right now, and that's fine, and other people say, no, they have to leave right now.
I'd tell you the one good thing, we're willing to share equipment.
Yeah.
So, we're a resource, we don't expect you to expend, all of your resources on it. Or, did you have a question?
No, I was just gonna say, it's 30 to 40% of maximum performance between the two. They're kinda like water and oil.
Yeah. So the real problem is when the vertically polarized only guy is talking, for example, the other guys can't talk, and that's.
Right, and it's not taking full advantage of the 802.11 in protocol, which is more than one a summation. So like 3, we're getting much, 4, we're getting higher speeds.
Right.
We go to 1, well, what are we doing that for? So, and it's the noise immunity too. The radios, we don't have a way to tell whether they're horizontal or vertical polarization, but you can infer that some links are using that horizontal chain over the vertical chain. Because of the way the antenna pattern, we can infer it's like, well, okay, we're off to the side, we're getting a really strong signal versus the vertical pattern not being as strong as the other.
Yeah, and thought about that, yeah. Okay, thank you.
In Nemo, the power is divided between the 2 chains. If he's vertical only, he's only hearing half the power from the Nemo station.
Right. There's lots of reasons to do it. The
Mhm.
question was, how bad is it for the other users? And
You can
that's-
try.
Oh,
You can- I would honestly say, put it on the air and give a comparison.
yeah, and that, yeah. Okay. Well, a specific example I've got is, we've got one guy that's running because of his location, he's running a 3-foot horizontally polarized only dish. And that's real money to him, okay? So, and he needs the gain, so for him to go out and buy an equivalent MIMO setup is $150, $200.
And I think the advantages of throughput and having the vertical and horizontal polarity
That's true.
would outweigh for the network performance.
Yep. But at least it's working right now.
He's on the air.
Yeah, that's my point.
How far is his link? What's he doing with that?
20, 25 kilometers.
Any other questions?
Great talk.
Could you
Yeah.
put
Thank
the
you.
title slide back up?